Hi, this video is about solving problems involving Ohm's law. So let's look at a few examples. How much current flows in your car's starter motor when it connects to your 12.0 volt battery if its resistance is 8.50 ohms? So I start by labeling the things that I know and what I don't know using the mathematical symbols with Ohm's law. So the voltage is 12.0 volts. The resistance is 8.5 ohms, and the current is what I'm looking for. So it's how much current. Current is symbolized by the letter I. So Ohm's law says the current is equal to the voltage over the resistance. The current is 12 volts divided by 8.5 ohms, and so when I put that into a calculator, I get this long number here. I'm using rules of significant figures, and so I have 3 significant figures for both my voltage and resistance. So I'm dividing them together. That means my final answer should also have 3 significant digits. So 1.41 amps. All right, let's look at another example. What is the resistance of a clothes iron that draws 12.0 amps from a 120.0 volt outlet? So 12.0 amps tells me that's a current. Amps is what we measure current in, so that's I. And then voltage is pretty easy to remember, it's volts, okay? So the resistance is what we're looking for now. So this is Ohm's law, I equals V over R. But if you want to solve for the resistance, then you can use this little math trick with the triangle here for this particular equation. If you want to find the resistance, you cover it up, and then you do the math operation that's remaining, so voltage divided by current. Now that works for all the other symbols as well. If you want to know the current, you cover that up and do voltage over resistance. If you want to know the voltage, cover it up, I times R. But we're doing resistance, so that's voltage over current. So 120 divided by 12, that's 10.0 ohms. And we have 3 sig figs for this one, so that's what I have, 10.0. All right, let's look at one more example. This one's also very common. Seeking to lead his troops into battle, an army general shouts, "Charge!" At this moment, a cloud overwhelmed with excess electrons breaks apart enough air molecules to create a lightning strike with a temporary current of 120 amps. 120,000 amps. If the broken down air has a resistance of 0.0045 ohms, what is the potential difference between the cloud and the ground? Okay, so the current from the amps here is 120,000. The resistance is 0.0045 ohms. It says what is the potential difference, and that's another way of saying voltage. Voltage is the potential difference between 2 different points in a circuit. So the voltage is what we're looking for. So we'll take Ohm's law here and we're going to solve for the voltage. Remember, we can cover up the V and we're left with I times R for the voltage. So doing that, we have 120,000 times 0.0045, and then that gives us a voltage of 540 volts. So that's all I've got for you in this video. Remember, shortcuts make long delays.